Hello teacher, hello students, welcome to today's lesson on the construction of auxiliary views. In our last lesson, we have seen the projection of basic geometric figures, which are point, lines, and plane surfaces. Let's briefly revise the previous lesson as usual. In previous lesson, we have seen the basic projection methods of point, line, and a plane along with their different cases. We have developed the concept of projection, principal and oblique lines, along with the construction of true length and point view of a line. Then we upgrade the concept of projection to a two-dimensional level, projection of planes. Planes can be normal, inclined, or oblique. Finally, we have seen the methods of projecting an edge view and true shape of the plane. In previous lessons of this chapter, we have defined auxiliary views as an orthographic projection view on a plane that's not one of the principal planes of projection. Well, let's define what are the principal planes in orthographic projection once again, and by extension, let us illustrate the auxiliary views as well. The glass box projection method is used to show the 6 principal views of an object orthogonally. Ortho means perpendicular. In this case, the visual rays from the observer are projected perpendicularly to the 6 projection planes of the glass box. The views of an object projected on the faces of the glass box are called orthographic projection views of an object. We have 6 principal orthographic views of an object on each face of the glass box. Notice that when the surface of the object is parallel to the principal planes, the orthographic view of that surface has the true shape of the surface on the object. Well, let's test the orthographic projection knowledge of yours. Since you have been doing projection of 3-dimensional objects from grade 11 lessons, it shouldn't be hard for you. Draw the 6 principal view of the object using your multiview drawing sketching skills. Go ahead and do that now. Well, did you do well on the revision of the multi-view drawing? I'm sure you did. Now, let's see the projection of the object from the activity by putting it into a glass box. While you draw multi-view drawing, you might not have to sketch the glass box. You can just visualize it in your mind. The principal views of the object will be found when the glass box is unfolded totally and stretched on a single plane. But some objects might have shapes that their principal faces cannot be assumed parallel to the regular planes of projection. In other words, they have certain details that are on planes that are not parallel to any of the principal planes of projection. Any other orthographic views which are not among the principal views are called auxiliary views of the object. Even though there are an infinite number of auxiliary planes, specific auxiliary planes are chosen to a specific object according to its surfaces. Auxiliary views are used for determining the true length and inclination of a line, the point view of a line, and edge views of a plane, the true shape and size of a plane, the distance between two skew lines. In the case of our today's lesson, auxiliary views are used for determining the projection of solids. Auxiliary views are also used to find the true shapes of sections of solids and curves of intersections. It might come to your mind that what is the difference between inclined and oblique surfaces? The word inclined and oblique refers to the angle which is made by the object's surface and the principal planes of projection. An inclined surface is a surface of the object which makes angle with two principal planes. For example, this surface makes an angle with the horizontal planes. This one makes an angle with the vertical planes, and this surface makes an angle with the profile planes. Oblique surfaces make an angle with all the principal planes of projection. The main concept to focus is that the orthographic views of an inclined and oblique surface on the principal projection plane give a distorted and foreshortened view of those planes. Foreshortened surface on multi-view drawings do not give a clear or accurate representation of size or shape and shouldn't be dimensioned. An auxiliary view allows the viewer to look perpendicular to an angled surface to witness the true size and shape of that surface and its features. The true shapes of these inclined and oblique surfaces could be projected on the auxiliary planes, which are parallel to the surface and projecting visual rays from the surface perpendicularly to the auxiliary planes. Remember, students, in the application of auxiliary views, the basic concept of the orthographic view is not totally changed. The viewer is still at infinite distance to the object, and the visual rays are still parallel to each other. The three-dimensional illustrations you have seen earlier should be transferred into the two-dimensional multi-view drawings. Let's see that now. To project the auxiliary view of an object, first, at least the two principal views with their reference line should be given. Let's see the construction of auxiliary views for the object with an inclined surface. Inclined surface appear as an edge view on the projection planes which are perpendicular to it, and it appears foreshortened on other views. To construct the auxiliary view, first draw a light reference line which is parallel to the edge view of the principal view. This reference line represents the auxiliary plane of projection. Then draw projection lines perpendicular to the edge view of the inclined plane, starting from the edge view itself. The number of projectors increases according to the intersection and end of edges lie on the edge view. These projectors are parallel to each other and perpendicular to the edge view and the reference line too. Using your compass or dividers, transfer distance from the principal plane's reference line to the auxiliary plane's reference line. Finally, darken all object outlines of the primary view and erase all projectors and reference lines. The completed primary auxiliary view showed the true shape of the inclined surface. Well, aren't you going to try the construction of auxiliary view for an inclined plane? Alright then. Try to find the true shape of the inclined plane on the object. I will give you the necessary dimensions on the auxiliary views, and you will have to draw the vital principal views first, but if you are using freehand sketching, use your scale of estimation. Go ahead and do that now. Welcome back. Did you get it right? Let's illustrate the solution with a simple video. Well, I hope you have done great. Students, do you remember the steps to find the edge view of a plane from our last lesson? We have said that an edge view is the orthographic projection on which the projected plane appears at the line. Let's revise it with a triangular plane. To find the edge view of a triangular plane, first draw a horizontal line from one of the vertex to the opposite side of the triangle. Construct the projection of the horizontal line on the other view of the plane. This line is obviously the true length of the horizontal line. Set up an auxiliary view perpendicularly to the true length of the line to find its point view and the edge view of the plane as well. As we have said in the first part of this lesson, oblique planes are planes which make an angle to all the principal views. Its surface appears foreshortened on the principal views too. To find the true shape of oblique surfaces, we will need to find its edge view first. First, draw at least two principal views. To project the edge view of the oblique surface, start by drawing or taking any horizontal line and project it on the other view. Draw the edge view by setting an auxiliary view which is projected perpendicularly to the true length of the horizontal line. While projecting the edge view of the oblique surface, it will not be necessary to project the other surfaces of the object too. To find the true length of the oblique surface, we just have to set a reference line which is parallel to the edge view and project another auxiliary view. Well, it's time that you practice the projection of an oblique plane. I'll give you the axonometric projection of an object with an oblique face. Then draw the principal views and find the true shape of the oblique surface. Use your sketching skills to save some time. Did you find the true shape with the right method of construction? Let's see a simple video to illustrate the solution. Good. In today's lesson, we have seen the construction method of auxiliary views for three-dimensional objects. Let's briefly revise what you have learned today. Among the different methods of projection, the glass box method helps in developing the 6 principal views of any object. The surface of the object will be projected to the principal planes with its true length if it is parallel with the project plane, but it will have a distorted or foreshortened view if it makes an angle with the projection planes. We use auxiliary views to go around this problem. Auxiliary views are made with the projection planes which are perpendicular to the inclined or oblique surface of the object. Inclined surfaces are planar faces which makes an angle with the 2 principal planes, while oblique surfaces make an angle with all the principal projection planes. To find the true shape of inclined surfaces, we need to set a reference line parallel with the edge view which represents the auxiliary plane which is parallel to the surface. While in the case of oblique plane, we need to find the edge view of the oblique surface first. To do so, we set a horizontal line on one view and project it on the other view. By adding one more reference line, which is perpendicular to the true length of the horizontal line, it provides the point view of that line, and projecting other points of the plane gives the edge view of the oblique plane. To find the true shape of the oblique plane, follow the steps the same as the inclined plane from the edge view. Well, students, that brings us to the end of our lesson for today. Keep on practicing on the projection of auxiliary views. In our next lesson, we will learn about the primary and secondary auxiliary views. Until then, thank you, teacher, and thank you, students. Goodbye.